Alright, on this last video, we talked about how to create the equation of a circle using the center and the radius. This video we're going to talk a little bit more algebraically how to do so without the graph being given. Obviously, if the graph is given, we can identify the center, we can find the radius using the lengths that we see. Algebraically, we need to interpret the information that's given and then figure out how to find that center and radius, because we still need that center and radius to build the circle. So on this section, we're going to write the standard form of a circle with the given characteristics. Sorry, that should say the standard form equation of a circle. And a lot of it's given straightforward, others we're going to have to interpret a little bit. So on number 5, it says a circle with radius 10 centered at 8, -6. Now again, I wrote the standard form up here just to remind us. Remember, the center is our h and our k, and we do the opposite of those values. So it's kind of like saying -h, -k, we're going to do the opposites, and then our radius here is 10. So the information is given to us on this one, so we just do x minus 8, because that's the shift in the x direction, plus y, and then we're going to do a plus 6, because we do the opposite of what's given as the -6. Don't forget to square each of those pieces, and then it's equal to r squared. So 10 squared is 100. 6 is very similar. Again, if we know that our h and our k are given here as the center, again, make sure that that is the center that's given, then the radius is 7. So we are going to say x minus 3 squared plus y plus 1 squared would be equal to 7 squared, which is 49. Okay. And the next one, same idea. This one has the center at 0, 0. So we talked about in the last video, if you feel more comfortable putting in the zeros to help you keep track of your center, you can do that, or simplify it down so that it looks like x squared plus y squared, since you don't need the zeros. Now, if we take the square root of 6, remember this is r squared on the end. So if we take the square root of 6 and square that, the square root and squaring are inverse operations, right? So it just leaves the 6 there as what it's equal to. So this would be our equation. Now these last few we're going to interpret a little bit before we just plow through calculating. Notice on number 8, it's asking you to find one, and it gives you the endpoints of a diameter. So first of all, we have to know what the diameter is, right? We've practiced with that on the last few assignments. Diameter goes right through the center of the circle, right? So we know that this is the center right here in the middle, and it's halfway between the endpoints of the diameter. So if one of these, and again I didn't put it on a graph, but if one of these is like -1, 6 and the other one is at 9, 2, then the center must be at that midpoint. I know my line doesn't look completely straight, but it must be there at the middle. So one of the formulas we're going to want to use is the midpoint formula, and I'm going to write it off to the side just so that we have it here. The midpoint formula is just the average of the x's and the average of the y's. So if I have a point, I just take the x values of each of those and I divide it by 2, right, finding the average, and then I do the same thing with the y. And we've used that a little bit this year. Just a reminder, there's our formula there. So I need the center, but I also need the radius to build the equation. Notice that the radius is going to be from that center point I find here. That right there, right, is the length of the radius. So I'm going to use the distance formula, so I'm going to write one more over here to help me find that. And you can find the distance of the whole diameter and take half of that if you want to, or find the center and then use the center and that endpoint of the diameter. So remember, the distance formula was when we took the square root of, we did x2 minus x1 squared and y2 minus y1 squared. So there's our distance formula. So we're going to do both to find, and these are just our formulas over here helping. So first let's find the center. So if I want to find the center, again I do the midpoint, and we could call this x1, x2, and this one, oh dear, let's not call those both x's. x1, y1, x2, y2. So again, we're going to add our x's together, a 9 plus a -1, or 9 minus 1, same thing. 2 plus 6 is our y values, and then we simplify. So 9 minus 1 is 8, divided by 2 is 4. 2 plus 6 here divided by 2 is also 4. So it looks like our center there is at 4, 4. So we're good with that. Now we just need a radius length so we can build the rest of our equation. So again, to find the radius, we use the distance formula. Now I'm going to use the center point of 4, 4, and then I'm going to use the end point of 9, 2. You can either do this side or you could do the other side if you wanted to. But again, I'm going to choose this one and then use this one and do those two. So I'm going to do x minus x, so 9 minus 4 squared. And then your y value minus your other y value, so 2 minus 4 squared. Okay, then we just simplify. So 9 minus 4 is negative 5. And 2 minus 4 is negative 2 squared. That gives me, right, anytime you square a negative number it becomes positive, so 25 plus 4. And it looks like our radius is the square root of 29. So then we just put those things in and build our equation. So we're going to have, right, x minus 4, because there's my center, my hk is right there. Square that, and then y minus 4, both of those, equals the radius squared. So again, remember if you square a square root, it just leaves the inside there. So there's that guy. Number 10 is very similar to this one. I'm not going to work through number 10, but it's the same process. You need both of those formulas. Number 9, the point 3, 4 on the circle with a center at 1, 4. Recognize again that if I had a circle here and this is the center, it told me that the center, you got to recognize what information is given, is at 1, 4, and a point on the circle. That means it could be in any direction. Now you may be able to actually plot the graph and figure out the radius on one like this or one like the last one. But again, if it's just some random point on the circle, 3, 4, then again, I just need to use the distance formula to help me find the radius length. So I already know the center. I know that my h and my k will come from the 1 and the 4. I just need to find my radius. So again, I'm going to use the radius and find the distance between these 2 points. So I'm going to do x minus x, 1 minus 3. And it looks like both of my y values are 4s. So when I simplify this, 1 minus 3, that's like negative 2 squared plus, well, that's just a 0. So really this is like the square root of 4, which is 2. Okay, so I'm going to use my h and my k again from up here, and then there's my r, so I'm going to have x minus 1 squared plus y minus 4 squared equals r squared, so I square this guy and put 4 right there. Okay, interpreting the information that you have, and then find the center and radius, always, always. Alright, lastly, we did some nonlinear systems earlier this year. We had parabolas being intersected by lines that look like this first example right here. Remember, sometimes there were 2 intersections, sometimes it just touched once, sometimes they never touched, so then there were no solutions like this guy over here. Now you just have a couple circle equations thrown in there. So they work the same, you still need to use all the algebraic knowledge that we've gained this year. But again, you can have 2 solutions, and they're the points where they intersect. Sometimes they never intersect, so you have no solutions once again. Algebraically, that's what happens, right, when you get an imaginary number in your answer. Or it could be that it's tangent to the circle, so there's only one intersection. So I'm going to work through these ones pretty quickly. Again, you're going to practice a couple of these on your assignment today. So the first one, we talked about you can solve these graphically. If you want to pull up Desmos and graph these, you can find their intersections actually pretty easily. If not, we need to solve them using substitution. So we take this guy and we plug it in for y, because that's what y is equal to. So we go x squared plus, and then we put that in there, is equal to 2. Again, we're just substituting this in to our equation. Sorry, I forgot that squared. Now remember, it's tempting when you're simplifying this to put the squared in. We talked about you can't do that with a binomial. What that means is that there's 2 of those. So you've got a negative x plus 2 and a negative x plus 2. And then we need to FOIL that out. So I'm going to quickly do that. I still have the x squared out front. When you multiply those 2 negatives, you get another x squared that's positive. Negative x times 2 is negative 2x. There's another negative 2x, and 2 times 2 is 4. then we just combine all the like pieces. So you've got 2x squareds here, which means it's 2x squared. Negative 2 and another negative 2 gives me negative 4x's. And then let's subtract this 2 over here. So we have positive 2. Notice that's just a quadratic, so we can solve it any way that we've practiced this year. But let's divide a 2 out since everything's divisible by 2. We get x squared minus 2x plus 1, and that's equal to 0. That guy's factorable, so we're going to have x minus 1, and it looks like our solution here deals where x is equal to 1. So remember, your solution is a point. So I just know that x is going to be 1, and now I need to find the y value. So we take this guy and we just plug him right back into that original equation there. So we have y equals negative, we put our x value that we found in 1, plus 2. So negative 1 plus 2 is just 1. So that means that this y value down here would be 1. Okay. Again, this one's a much more complicated one. I feel like this is as complicated as it can get, but notice that the steps are the same, and they're just the algebraic pieces that we've dealt with. So again, we're going to take this and we're going to plug this in where y would go in the equation. So we're going to have x plus 4 squared plus, and then inside of here I'm going to put in that x plus 5, and then you still have that minus 1 squared is equal to 4. Now I wrote it small, not that that means anything, I'm not sure why I wrote it small. Okay, so now first of all we have x plus 4 over here, and we have x plus 4 over here. On the inside here, it looks like we have x plus 5 minus 1. That's the same thing as x plus 4, right? 5 minus 1 is 4. So you actually have 2 more of these, plus 4, x plus 4, and then equals 4. So again, we're going to FOIL these out. So we're going to get x squared plus, you're going to get 4x plus 4x, which I'm going to already combine those as 8x, plus 16. Then this guy's exactly the same. So x squared plus 8x plus 16. And combine your pieces. So you've got x squared and x squared, that's 2x squared. 8x and 8x, that's 16x. 16 and 16, that's 32. And we want to equal to 0, so we minus the 4 this way. So 2x squared plus 16x plus 28 is equal to 0. Notice these are all divisible by 2 again, so it makes our life easier if we just divide out a 2. X squared plus 8x plus 14 equals 0. Now this one you can try and factor it. It's not factorable in a nice way, so instead we need to use the quadratic formula. So remember, we identify our a, our b, and our c. A in this case would be 1, and we start to plug that in. So remember, x is equal to the opposite of b, so that would be negative 8, plus or minus the square root of b squared, minus 4 times a, and a in this case again is 1, times c, which in this case looks like is 14, all over 2a. From there, you guys have practiced this, we just simplify. So negative 8 plus or minus the square root of, if you plug that in your calculator, you'll end up getting 8. Because 64 minus, that gives us 56 over here, is 8. So all over 2. And then remember, we always simplify the radical if we can. So 2 and 2, it looks like we have a group of 2's. So this guy right here is going to be negative 8 plus or minus, we pull the 2 out front of the radical, and that little 2 that's over here is left inside, all over 2. Now we think we're done, but look at these coefficients. They're all divisible by 2, so we divide out a 2. And we get negative 4 plus or minus. Now if you divide 2 by 2, you just get a 1, right? And a 1. So we don't actually need to write those 1s. So this right here represents our x values. Now, because there's a plus or minus, remember those are going to represent 2 different solutions. So there's going to be 2 different points where these cross. And the first one is going to be negative 4 plus square root of 2 as the x value. And it looks like the other one will be negative 4 minus the square root of 2. Now I know it looks very complicated, but we can just leave it in exact form and just plug that in for your x value to find your 2 y values. Okay, so here's my y. Y is equal to x plus 5. Well, if x is negative 4 plus the square root of 2, plus 5, then we just simplify that. That's our y value. So we've got a negative 4 and a positive 5, so that's going to be 1 plus, and we just bring down that square root of 2. So that's my y value associated with x being negative 4 plus square root of 2. And then you just do it one more time for your other one. So y is equal to, again I'm using red so you can see where I'm plugging in the x value that we got. So there's our next x value. And still plus 5. So this is actually going to look very similar. Negative 4 plus 5 is 1. And then bring down, but it's a subtract square root of 2. So that would be your y value. Okay. So you're going to work through these. Remember, if you get an imaginary number in your solution, then there is no intersections. There's no solution. For my honors kids, you have one more little video to watch on creating the equation.